guys, I am Kumar K, your favorite teacher for TSA plus OA plus CP. Today we are going to solve a very interesting problem. This one. This problem was asked in Codeforces recent Div3 round. It is the problem E. Okay. Now, before I start discussing about this problem, there is something very important which I want to tell you. See, there are two ways to solve this problem. Okay. One way is that you have done two pointers, many standard easy problems you have done from many standard DSA sheets. When you do like that, you kind of memorize the two pointer pattern. If you have done that, you will not be able to solve the problem. Another way is that you have a very deep understanding of how two pointer is nothing but directly related to the monotonic increasing, decreasing, or we can say two pointer algorithm is nothing but a standard application of greedy algorithms. If you know that there is a very deep relation between two pointer algorithms and greedy algorithms, then this problem, as you see it, you can just solve it on the spot. Okay, on the spot. So let's say you do not know how to get this deep level of understanding and all the secret tricks of two pointers. I have made the best warm up DSA plus OA plus CP course for you people. Just go to the link in the document, complete the two pointer problems from there. Once you complete them, come here in the video. By then, you would be knowing the solution for this Codeforces fifth E problem as well. Okay, so let's go there. So if I go to this problem, this problem you guys already know. We are going to talk about it, right? You guys know about it. No issues, no problem. This is the warm up course you should try to do. Like, even the student of mine who you must be knowing that recently my student cracked off campus offer from Google, so even she did this prerequisite course. You should also do. Okay, so in this prerequisite course, if I scroll below, there is this very nice two pointer basic warm up course I have made with the very deep level of understanding, explaining the monotonic concepts, the increasing decreasing order concepts. I really want you to master it. Please do it before you watch this video. Okay, and if you already have the good knowledge of two pointer, then you can continue watching this video. So I want you to complete this one, masterclass foundation Microsoft OA problem of two pointer, then Google SD3 interview part 1 and part 2 hard follow up of the two pointer problem. Okay, now if you are someone like third year student or fourth year student and you want best level beginner to advanced or intermediate to advanced DSA plus OA plus CP daily life training by me, personalized one-to-one mentoring by me, and many more support facilities, helps, and direct fangam job referral support, you can check out our training program. Currently discount is going there on the September cohort. Now from October the prices are increasing. So if I talk about the prerequisites, the prerequisite thing is clear to you. Okay, now what is this problem saying? This problem is saying that an array is given to you. Okay, an array is given to you, no problem. Now in the array they want you to find good valid subarrays. What is a valid subarray? A valid subarray is a subarray which has exactly k distinct elements. That's their definition. A valid subarray is a subarray which has k distinct elements. Apart from that, the length of that subarray should be in the range L to R. So what will you do now? How to solve this problem? See, they are asking you something very complicated. They are asking you count of valid subarrays such that there are exactly k distinct elements in it, and the length of the subarrays which are valid should be from the range L to R. This is very big. So you always need to know how to break down the problem. So let's try to make it easy. First, let's try to solve some easy versions. So forget about LNR. How will you count C1 of K? Forget about LNR. Just tell me, if someone asks you that, hello, Kumar K student or my YouTube community student, given an array of positive negative integers or any type of array given to you, how will you find out how many subarrays are there in this array such that they have exactly k distinct elements? Some people might say two pointer. Yes, correct, but you cannot directly apply two pointer here, because two pointer in general, what two pointer in general does, c1 of k you cannot directly calculate. What you can calculate is a different function, count of k. Count of k is nothing but calculates the number of subarrays, count of subarrays which have greater than equal to k distinct elements. Okay, this is a standard problem. This is a standard concept. Using this concept, we can do as many things as we want. So, given an array, guys, do you know how to find out how many subarrays are there which have greater than equal to k distinct elements? I to j property. This is same as finding the number of subarrays in a positive array such that the sum is greater than equal to k. I pointer, j pointer. If I to j is valid, if I to j is invalid, if I to j does not have k distinct elements or the sum you have not reached it, you will try for I to j plus 1. If that also fail, you will try from I to j plus 2. If you that also fail, you try from I to j plus 3, I to j plus 4. Then I to j plus 5. If I to j plus 5 is valid, that means that I to j plus 5 is the smallest valid subarray starting at index I. And if I to j plus 5 is valid, then all the other subarrays I to j plus 6, I to j plus 7 till I to n will be valid. Okay. So this concept you need to know. Now, when I'm telling you these things, I assume you have done my prerequisite course and you know what I'm trying to say. Okay. So today, like, I don't have my, writer board with me. So it will be difficult to, show you the visualizations. Anyways, we forget everything and now we only focus on count of k, the number of subarrays which have greater than equal to k distinct elements. So if I try to show you in the document, think about the standard two pointer greedy and how the subarray I to j moves when you are trying to find the subarrays with greater than equal to k distinct elements. Count of k. I will think about the standard two pointer greedy and how the subarray I to j moves when you are trying to find subarrays with exactly k distinct elements. Let it be c1 of k count of k minus count of k plus 1. I will read it again, but before that, count of k. If I to j is having less than k distinct elements, we move to I to j plus 1. And if I to j plus 1 has greater than equal to k distinct elements, then I to j plus 1 indicates that for index I, the smallest valid subarray is I to j plus 1, and hence I comma j plus 1, I comma j plus 2, I comma j plus 3 till I to n all are valid. Okay, all are valid. So let me show it to you via a small visualization. Even though I don't have my writer pad with me, I'll have to write it with the mouse. Anyways, there were some technical issues. Okay, not technical issues, just a personal issue. I forgot to bring it in the office. Anyways, now listen. I equal to 1, j equal to 1. Okay, so we are considering this subarray. Guys, k equal to 2. Does this subarray has two distinct elements? If you consider the subarray in this example from I equal to 1 to j equal to 1, does it has two distinct elements? No. So what will you do? Common sense लगाओ. अगर इतने से सब एरे में k डिस्टिंक्ट एलिमेंट्स नहीं है तो उसको बड़ा करके चेक करोगे ना, क्योंकि बड़ा करोगे तो और एलिमेंट्स आएंगे तो प्रोबेबिलिटी इंक्रीजेस, राइट? प्रोबेबिलिटी इंक्रीज हो जाती है कि हाँ आपके डिस्टिंक्ट एलिमेंट्स होंगे उसके अंदर. क्लियर? Currently how many distinct elements are there? Only one distinct element is there. You want two or more than equal to two distinct elements. So what will you do? You will now make your j from 1 to 2. Now this is the subarray you are checking. Subarray from index 1 to index 2. Does it have greater than equal to two distinct elements? Yes. Hell yes. Ram Ram. Yes. In every ingoing and outgoing breath, always chant the name of God Ram Ram like this. It will lead you to moksha. Okay. And that's what you need. The most important thing in your life. Okay. Now, going back to the problem. The problem is that you know that from I equal to 1 to j equal to 2, 1 to 2 is a valid subarray. Okay. Okay. Like I'm considering one based indexing. This is index 1, index 2, index 3, index 4, index 5, index 6. Okay. So 1 to 2 is a valid subarray. This conveys that now you don't need to check any other subarrays. This means that 1 to 2, if 1 to 2 is valid, it means 1 to 2 will also be valid, 1 to 3 will also be valid, 1 to 4 will also be valid, 1 to 5 will also be valid, till 1 to 6 all will be valid. So guys, this is the basic two pointer concept. If your two pointer, the starting pointer is I, if you come to know that I to j is valid, this means that I to j, I to j plus 1 till I, from I till the end of the array, all these subarrays will be valid. Why? This has k distinct elements. So the bigger subarrays will have always greater than equal to k distinct elements. If this subarray I to j, you have found a valid subarray I to j, okay? If this subarray from I to j, let's say k equal to 5, it has 5 distinct elements in it. The elements might be repeating, but there are exactly 5 distinct elements in it. Now, if you move the j pointer, one more element is coming. पहले 5 डिस्टिंक्ट एलिमेंट थे, अब आप उसमें और एक डाल रहे हो, तो वो या तो 5 रहेंगे डिस्टिंक्ट या तो 5 से बढ़ेंगे. कॉमन सेंस, राइट? So if I2j is valid, I2j plus 1, I2j plus 2, all those subarrays will be valid. All of them will be having greater than equal to k distinct elements if it is confirmed that I2j has exactly k distinct elements. Okay. So this is the standard two pointer concept, right? What you do is that this is your I and this is your j. Let's say I to j is not valid. It does not have k distinct elements. You will try from I to j plus 1. If this is also not working, you will try from I to j plus 2. So for this particular index I will not shake. I will stay at j I equal to 1 only. We will keep on incrementing the j until we find the minimum length subarray starting at index I, which has greater than equal to k distinct elements. Once you find that, once you do that, your task is done. Why? Your task is done because you have found the smallest subarray starting at index I, ending at index j, which is valid, which has k distinct elements. Because it has k distinct elements, all the others are also valid. So if I to j is valid, if I to j is valid, all these are valid. So total, how many valid subarrays are there for how many valid subarrays are there starting at index I, which have greater than equal to k distinct elements? They are nothing but j, j plus 1 till n. So the count will be n minus j plus 1 because I to j will be valid, I to j plus 1 will also be valid. So how many are there? It is nothing but the amount of numbers from j to n, which is n minus j plus 1. Okay. So the same thing I have shown here, you guys can see, like for each index I, the smallest j you now can calculate using the two pointer algorithm such that I to j is valid and the count of all the valid subarrays starting at index I will be n minus j plus 1. If I try to show you the code snippet, which is very, very great actually. So let's try to go towards the code snippet, okay? Code snippet is really, really great. I made it specially for you, okay? I got it made for you. Yeah, I think I asked ChatGPT for it. Anyways, so guys, you can see I remains there only. J less than n until the distinct element strictly less than k. So now a new element a of j is coming in our window, right? Sliding window. So if this element is a new element, frequency 0, obviously when you're going from I to j, you need to maintain all the elements from I to j in a hash map. So you can know how many distinct elements are there in the window from I to j. If you don't know the hash map concept, go to my prerequisite course and do the hashing course. Okay, those all things you need to know in advance, guys. You need to know in advance. Okay, in advance you need to know those things. Clear? So let's go. Yeah. So that's it. And once you find that, once you know your smallest valid subarray from I to j, now you just need to do I plus plus. Now, see, let's say for I equal to 1, you know the valid j. So now what will you do? Now I will increment I to 2. Now I want to find what is the best, what are the valid subarrays starting at index I equal to 2. So from the hash map, I will remove the one element which is at I equal to 1. Okay, that's it. So I just remove it, okay, and move the left boundary, and that's it. Okay. So for each index I always know the smallest j such that I to j is valid and the count of all the valid subarrays starting at index I will be n minus j plus 1. Now, if all this is done, then what is left? So we are able to calculate count of k. But the question is, we are able to calculate how many subarrays are there in the array which has greater than equal to k distinct elements. But the question is asking, we only want the count of subarrays which has exactly k distinct elements. What will I do in that case? Okay, what will I do in that case? Let's think about it. So in that case, you can just write the formula for exactly k distinct elements. C1 of k is nothing but count of k minus count of k plus 1. So if I try to show it to you visually, count of phi means what? Count of phi means all the subarrays which are having 5 distinct elements or 6 distinct elements till at max there can be n distinct elements or something less than that. This is the meaning of count of 5. Okay, what is the meaning of count of 6? All the valid subarrays which has 6 distinct elements or 7 distinct elements till maximum worst case n distinct elements. So if you do count 5 minus count 6, what will happen? If from this you subtract this, thus this part, this red part k6 to kn is same as this. So only k5 will be remaining. So guys, C1 of phi is nothing but count of phi minus count of 6. Only K5 will be remaining. K5 tells us exactly how many subarrays are there which has exactly K5 distinct elements. So C1 of K, which the question wants, the number of subarrays having exactly K distinct elements is nothing but the number of subarrays which has greater than equal to K distinct elements minus the number of subarrays which has greater than equal to k plus 1 distinct elements, and the problem is solved. So guys, the problem is solved now, right? Good. Now the only thing is remaining is that L and R concept. Okay, we need to know the L and R concept, guys. See, everything is done. You now know how to find the total number of subarrays in this array such that there are exactly k distinct elements in it. Now they have added one more condition. That one more condition is that Khiladi 786 Akshay Kumar movie, I remember. I'm feeling good like him. Now listen. So what were we talking about? We want the valid subarrays to have the length in the range from L to R. L to R. We want the length to be in the range L to R. So now what to do? We want the length to be in the range L to R. Okay. So we want the length to be in the range L to R. We want the length to be in the range L to R. So, well, say, let's try to calculate count of k comma u. Count of k comma u is nothing but the valid subarrays which have greater than equal to k distinct elements, and the length of those subarrays is greater than equal to u. Guys, new concept I am introducing, count of k of u. So what is the meaning of count of k of u? Count of k of u. The subarrays which have greater than equal to k distinct elements, but their length should be greater than equal to u. What do I mean to say? Let's say this is your I and this is your j. Okay? Okay, sir, no problem. While doing the two pointer algorithm, you have realized that I to j is valid. You have realized that for this I, this j is the smallest index such that I to j is valid. Valid means it has greater than equal to k distinct elements. Okay. It has greater than equal to k distinct elements. But we want the length to be greater than equal to u. Okay, we want the length to be greater than equal to u. Let's say u is equal to 2. U is equal to 2. But we know that the length from I to j is what? The length from I to j is what? Length from I to j is 4. Okay. Length from I to j is 4. So you know that for this index I, the valid subarrays having greater than equal to k distinct elements, they will have this length. One of them will be of length 4. Let's call it as n. One of them will have length 4. One of them will have length 5, 6, 7, till n. So guys, the valid subarray starting at index I having greater than equal to k distinct elements will have length 4, 5, 6 till n. You can see because j is the first smallest index which does that, right? But they are asking for the subarrays whose length is greater than equal to 2. So yes, whatever, all of them are greater than equal to 2 only. So what you have to do is, for each index I now, you need to know the smallest index j. Then you need to calculate this length. What is this length? This length is 4. If this length is already greater than equal to u, it is already greater than equal to u. We were trying to find the subarrays which are valid and whose length is greater than equal to u. But 4 is already greater than equal to 2. Then you don't need to worry. Just add all the valid subarrays from 4 to n minus 4 plus 1 to the count. All of them have the length greater than equal to. That's why it's written here. Using the same I to j concept for each I find the smallest valid j. Now length of our smallest valid subarray is j minus I plus 1. Now if our length is greater than u or greater than equal to u, whatever you want to say, it means I to j plus 1, I to j plus 2, I to n all will be counted towards valid subarrays having length greater than equal to u. Why? Because if I to j is itself greater than u, then all the bigger subarrays will also be greater than equal to u, and all we had to do is find the valid subarrays which are having greater than equal to k distinct elements. This we have checked already. I to j already has greater than equal to k distinct elements. Now one more u condition we have added. Can you see how everything is increasing and monotonic? It requires lots of logic and brain to know that whatever you are calculating, it should have greater than equal to k and greater than equal to u functions in it, because it is monotonic, 2 pointer greedy, going increasing, then j going like this, I going like this. You will understand it in detail if you go and do my prerequisite course. Okay, if you're a Kumar K student, you must be enjoying this, and even the YouTube community students watching me since few months must be enjoying it. Okay, so now listen up. All these things are done. So now what to do? So guys, it's now pretty simple. Only this case is simple. But what if u is greater than equal to l? Then only these subarrays are valid, right? It can happen that instead of 2, u was, let's say, 5. Now your, for this I, this j you are getting, right? So your code is saying that 4, 5, 6, 7 and all are valid. But u is 5. You can only consider the subarrays of length 5. So in that case, only from 5 to n will be counted as valid. 4 will not be taken, even though it is valid, because we only want the subarrays whose length is greater than equal to 5. So guys, घूम फिरा के बात यही है कि count of k comma u is a special algorithm which will immediately tell you all the count of the subarrays which are having greater than equal to k distinct elements and their length is greater than equal to u. Because fortunately, once you know the smallest I to j, we only talk about the increasing lengths till the end. They are also well. That's why we can use this concept here. Okay. So you know count of k of you have to calculate. Now, count of k of L of R is nothing but what? All valid subarrays having all valid subarrays having greater than equal to k distinct elements and their lengths are in the range L to R. Their lengths are in the range L to R. So guys, that's it, plus minus concept. Count of KLR. Okay, so why will this work? This is also simple. Okay, of count of K comma KL minus KR plus 1, right? Count of K comma 11, and let's say count of K comma 8. So what is the meaning of count of K comma 11? This means that all the valid subarrays, all the valid subarrays such that it has greater than equal to k distinct elements and its length is 11, or the ones which have greater than equal to k distinct elements or the length is 12 till like this, right? Till the length is n in the worst case, right? ckn. Count of k of 8 means all the valid subarrays which has greater than equal to k distinct elements but their length is 8, or their length is 9, or their length is till 10, 11, till worst case k2 and n might not even happen in some cases. Okay, so if you subtract this from this, what you will get? You will get count of, if you subtract this from this, ck8 ck9. Okay, sorry, I mean to say this is getting subtracted from this. So count k8 minus count k11. Count k8 minus count k11 is nothing but count of k comma 8 comma 10. So you are now able to know what has happened. If you subtract this quantity from this quantity, k11, k12 and kn will be destroyed, right? So this part after k9, after k10, this will be destroyed. So what will be left? K10 will be left, right? ck10, because ck11, ck12, ckn has been subtracted. So ck8, ck9, ck10. This basically means that all the valid subarrays having length 8, 9, 10. So count of k of L to R is nothing but count of k of L minus count of k of R plus 1. I know no one has taught you in such nice in-depth manner. So just keep on enjoying. Life is very good and nice. Just keep on enjoying it on a daily basis. Okay. So now this thing is done. Final question asked was what? C1 KLR. Final question asked was not count KLR. Final question was C1 KLR. C1 KLR means count of valid subarrays which have exactly k distinct elements and the lengths are from L to R. This is nothing but equal to count of all valid subarrays having greater than equal to k distinct elements having lengths from L to R minus count of all the valid subarrays, same as explained here, having their lengths greater than equal to k plus 1. You remember C1k is count k minus count k plus 1 having their length greater than equal to k plus 1, but the length should be from L to R. So you'll calculate all these functions and the job is done, done. Ram ram. Wow. So this is really nice. Really nice stuff. Such a great educational problem to master the concept of two pointers and this plus minus thing in that. Prefix suffix can also be, learned. This thing teaches you many things for the prefix suffix arrays and those problems as well. Okay, specifically the plus minus thing. Okay, so you guys can go through this code, you can just enjoy and understand it. Okay, You can see LR, same thing is happening here. Okay, okay, okay. So, Ram Ram. Make sure you like, share, subscribe if you got good value.